Welcome to Algebra 1. The learning goal for this episode is to learn the properties of zero and negative exponents and use them to simplify expressions. Let's look at this pattern for powers of 2. 2 to the fourth is 16, 2 to the third is 8, 2 to the second is 4, and 2 to the first is 2. Notice that as the exponent decreases, the value divides by 2 each time. So let's see if we can figure out what happens if we continue decreasing the exponent by 1. Can we figure out what 2 to the 0 must equal? How about 2 to the negative 1? 2 to the negative 2? And so on. Well, if we follow the pattern and continue to divide by 2, then 2 to the 0 would have to be 1. And if we keep going into negative exponents, for 2 to the negative 1, we would have to divide by 2 again, which would give us 1/2. Note that we could write 1/2 as 1 over 2 to the first. If we go one more step and divide by 2 again, for 2 to the negative 2, we would then get 1/4, which we could also write as 1 over 2 to the second. One more step, divide by 2 again, and we'd get 1/8, or 1 over 2 to the third. Hopefully, you're seeing the pattern here. This leads us to our definition of zero and negative exponents. Any number or variable raised to the 0 power is going to equal 1. Anything raised to a negative exponent is going to be the reciprocal of that same base raised to that positive exponent. Like our previous example where 2 to the negative 3 is the same as 1 over 2 to the positive 3. Likewise, you can think of a number raised to a positive exponent as the reciprocal of a number raised to a negative exponent. Let's look at some examples. We want to simplify this expression, which is a product of two powers, but this time involves a negative exponent. Using our product of powers property, we can simply add the exponents. This gives us 2 to the negative 6th power. We typically don't consider negative exponents to be in simplified form, so we want to write this with only positive exponents. To do that, we use the properties we just learned to write this negative exponent as the reciprocal of the same base to that positive exponent. So 2 to the negative 6th is the same as 1 over 2 to the positive 6th. Like before, we could expand out 2 to the 6th and write this as 1 over 64, since 2 to the 6th is 64. But we can also leave it in exponential form as 1 over 2 to the 6th. Here's another example. This time it's a power raised to a power. Again, I use my property, which means I can simply multiply those exponents. So I get x to the negative 6th, but I want to rewrite this as a positive exponent. So I write this as 1 over x to the positive 6th. This is considered simplified form. Let's try this example. When I subtract my exponents, I get x to the 0 power. Now careful, that is not equal to x. My property tells me that anything to the 0 power equals 1. Even without the property, this should hopefully make sense because you already know that any number divided by itself is 1. So therefore, if you look back at that original problem, x to the 12th divided by x to the 12th, which is dividing by itself, has to be 1. What if we had something that looked like this? I use my property and subtract the exponents. This gives me 3 to the negative 8th power. I can then rewrite that with a positive exponent to look like this, 1 over 3 to the positive 8th. I could expand out 3 to the positive 8th and get 1 over 6,561, but I could also leave it as 1 over 3 to the 8th. Example 5 looks a little more complicated, but we just really need to be careful how we apply our properties. Since this is a power of a power, I need to raise each factor to that fourth power. So I get 3 to the 4th, x squared to the 4th, and y to the negative 3 to the 4th. Simplifying, I then get 81, which is what 3 to the 4th equals, and then I can multiply my exponents for my bases. So I get 81 x to the 8th, y to the negative 12th. But this is not considered simplified because it still has a negative exponent. But I know I can take the reciprocal and make it a positive exponent, which has the result of moving the y to the positive 12th to the denominator. but the 81 and the x to the 8th stay in the numerator. You have to be really careful with negative exponents and making sure you rewrite them as positive exponents, but don't get that confused with a number like 81. That's just a number, not an exponent. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is simplify this expression involving both positive and negative exponents. How do we do that? We use our knowledge of how to rewrite a negative exponent using a positive exponent and the reciprocal. In this case, this ends up giving us the x squared in the numerator and the y to the positive 4 in the denominator. Since we only have positive exponents, we're done. Let's try another one. Again, we're simplifying an expression involving exponents. What do we do first? This time we have a constant and 2 distinct bases, x and y, so it's probably easiest to separate them out. What's next? We use our properties to simplify, getting x to the 0 and y to the negative 5th. Now what? We know anything to the 0 power is 1. And we know that we can move a negative exponent to the denominator and make it positive, so we get this, 5 times 1 in the numerator and y to the positive 5 in the denominator. What's next? Well, we simplify a little bit. 5 times 1 is 5, so we get 5 over y to the 5th. This is considered simplified form. Let's try another one. What's different about this one? This one involves a power raised to a power. So what do we do first? We need to raise each factor to the second power. So 9 to the second, a to the negative 2 to the second, b to the third to the second, and c to the negative 4 to the second. We have to make sure we raise each one of those factors to the second power. What's next? We begin to simplify. 9 squared is 81. a to the negative 2 to the second, we multiply those exponents and get a to the negative 4. b cubed to the second, 3 times 2 gives us b to the 6th. c to the negative 4 to the second gives us c to the negative 8. Now what? Now we can rewrite our negative exponents as positive exponents in the denominator. So the a to the 4th and c to the 8th are now positive in the denominator, but the 81 and the b to the 6th stay in the numerator. This is considered simplified form. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem and work it out in your notebook, then press play to check. Please pause the video now. Here is the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn the properties of zero and negative exponents. We did that by learning their definitions. Anything to the 0 power is 1. Anything raised to a negative power can be rewritten as 1 divided by that same base raised to that positive power, so writing it as the reciprocal.